Time travel is a widely recognized concept in philosophy and science fiction. But is it possible in real life? Is it possible to travel in the past or the future?
What if you could do all of these things in the blink of an eye, in the middle of space?
Imagine you have a watch that lets you travel through time. One day you have the bright idea to go back to the 1930s to mess with your grandparents. You press a few buttons and suddenly you're standing beside your grandfather, standing next to the precipice of the Grand Canyon.
Since you've never been the biggest fan of your grandfather, you decide to push him over the edge. Gravity does its thing, and seconds later,
No more puppy!
But wait, if you kill your grandfather before he even met your grandmother, you wouldn't have been able to go back in time. Here's the problem. If you didn't exist to kill your grandfather, you couldn't have killed him.
Because you didn't kill him, he's still alive. But that would mean you would also be alive, and thus be able to kill your grandfather.
This is what we call the grandfather paradox, and it's part of what makes time travel so interesting and
To some extent, a kind of time travel has been explained by Einstein's theory. In its simplest form, a pair of twins form an experiment. Let's name them Don and Ron. Ron heads off on a very fast rocket ship to a distant planet of the universe and comes back home. At the same time, Don stays on the Earth. Upon return, the two brothers find out that the one that stayed on the Earth aged more than the other.
This is a well-established consequence of relativity. It shows that time can tick faster or slower, depending on how you're moving.
what if I told you that a powerful way of manipulating space and time could exist in our universe? In fact, it is called a black hole.
Let's look at what would happen if you were to sink into a black hole. Imagine that journey as if you were swimming in a river that was ending into a big waterfall.
As you keep swimming, you would start to notice an increase of your speed due to the current induced by the waterfall. Getting closer and closer to it, you would cross a non-return point, from which no matter how hard you try, you wouldn't be able to swim back against the current. This would sooner or later end up in you falling to your death.
Well, this is basically the same for black holes. As your spaceship would be getting closer to it, the astronomous gravity induced by the black hole would increase your speed towards it. The equivalent of the non-return zone would be what is called the event horizon.
The main difference between the illustration and reality is the following. From an external perspective, you would start slowing down and turning red while approaching the black hole.
If you've been following and understanding of course our video so far, you probably remember what a wormhole is.
In fact, it has been theorized that wormholes may be tunnels in space-time that can theoretically allow travel anywhere in space and time, or even into another universe. In many ways, wormholes resemble black holes. Both kinds of objects are extremely dense and possess extraordinarily strong gravitational pulls for bodies of this size.
The main difference is that no object can theoretically come back out after crossing a black hole's event horizon.
In order to create a wormhole, a black hole would have to be connected to a white hole that has the opposite effect. It pushes away everything so that nobody would be able to get into it.
Connected to each other through their singularity, black holes and white holes would then theoretically allow space travelers to move in time or in a specific place of the universe, as the now created wormhole connects two places of the universe, not necessarily at the same time.
To summarize these 3 episodes, there is technically a way for us to travel in time like we do in space. Based on various theories and assumptions, like the fact that specific wormholes exist, we can theoretically hope to travel in the future or in the past in the next few centuries.
Thank you for watching our videos. Don't forget to leave a like and give us the maximum mark on laprepa.com.
We hope you learned things about black holes you didn't know before. If you have any questions, please do not hesitate to leave a comment below or to directly ask us tomorrow afternoon in class. Don't forget, knowledge matters.
This leads us to this question. What would happen if we travel through a friendly wormhole?
But this is the story for another What If.